going to replace a window today. This window that we're going to replace is an aluminum frame window, and aluminum conducts heat very, very quickly. It's the least energy efficient type of window frame that there is. And we have an aluminum window frame, aluminum window sash. And when we shoot these windows with a thermal imaging camera, we can see that the frame is desperately cold. I mean, really, really cold, almost the same temperature as the outside. So very energy inefficient windows. But we also have a thermal pane glass here. And so we have two panes of glass, but the seal somewhere around the perimeter of this glass has failed, and air is allowed to get inside in between the glass. And when that happens, the moisture that's in the air condenses and forms a fog. You can see there's a fog and water droplets on the inside of this glass. Very distracting, very ugly from the inside, so it's not something that anybody would be happy with. So we also don't have very energy efficient glass here. This is clear glass. It's not low E glass. Low E glass has a reflective film on it that will reflect heat in the winter, reflects the indoor heat back inside. In the summer, it reflects the outdoor heat back outside and lets the visible light through the window. We also have an option of argon-filled gas in between the panes of the glass, and the argon will doesn't transmit heat as easily as the air would in between the glass, so it makes a more energy efficient glass itself. Now we know that a window is the weak spot thermally in a wall assembly. The wall may have R13 insulation if properly installed and without air gaps and air leaks and so forth. We have an R13 wall, but a window might only be R1 or 2. So the window is going to be the coldest spot in the wall assembly. This is the new window that Dr. Energy Saver will be installing today. This window has low E glass. Now low E stands for low emissivity. And if we take a look here, we can see that what we're going to be doing with the low E glass is reflecting heat while letting visible light through. So only a small fraction of the solar heat will come through the low E glass in the summertime, and in the wintertime it will reflect heat from the indoors back inside rather than letting it through as well. So there's a coating on the inside of the glass that gives it a little tint that allows that to happen. Let visible light through, but stop the heat, the infrared radiation, that part of the solar spectrum, from going through the glass. Here's two samples of different glass. And now the one on the right is clear glass, and the one on the left is low E glass. So you can see it's a little bit tinted, kind of like sunglasses. So we can see that our low E glass is a little bit tinted, but that's going to give us a big benefit in energy efficiency. We also have another rating called solar heat gain coefficient. This window is 0.33. The lower the number, the better. And this measures how well the window is at blocking the heat from the sun. We have a visible transmittance rating. That's 0.56. It lets 56% of the visible light through there. And in the process of reflecting heat will also block some of your visible light like sunglasses would. But the important rating is the U factor on this window. And the U factor measures how overall energy efficient this window is. And this U value is 0.3, which is very good, very efficient window. The U value is the inverse of R value. So if we take 0.3 and divide it by 1, or into 1, we get 3.33. That's the R value of this window, 3.33. If we had a U factor of 0.5, for example, then 1 divided by 0.5 is 2. We have an R value of 2. So compared to a window with a U factor of 0.5, this one with a U factor of 0.3, we actually have 2/3 better energy efficiency overall with this window compared to a window with a U factor of 0.5. We also see that we have argon gas in between these two panes of glass. So the argon is more energy efficient. It's an inert gas. It does not allow the heat to be transmitted through that airspace in between the glass. So it can go, the heat can go from this glass to the air between the glass to the next pane of glass to the inside, and vice versa in the winter back out. But the argon will help prevent that heat flow. So that is a option and a characteristic of high efficiency windows. So this is energy efficient window. It does qualify for tax credits. It's energy efficient enough to get tax credits, 0.3 or less, if those credits were available in your area. And this is going to make a big difference for this homeowner. You know, oftentimes people complain of drafts from their windows, and that may be true. You may have leaky windows, but we know that glass is the coldest spot in a wall assembly. The glass will always be colder than the wall. And so if the glass is cold in the winter, we get what we call a convective loop, that the warm air in the room touches the glass and it cools down. When the air cools down, it sinks and it goes down to the floor, goes across the floor, up the interior wall where it gets warmed, and then it goes down again. And so here we are sitting next to the window and we feel a draft and we think that the window is leaking. Now again, it may be leaking, but we also have a convective loop from cold glass. And this is why high performance glass in an energy efficient window is important, because if we can keep that glass warmer and it's not so cold, we get less of a convective loop. Okay, so we have to put this window in, and there's a difference between replacing a window and a replacement window. When you replace a whole window, you take the frame out, you take the exterior trim out, and you put a whole new window in, and it's got to be flashed properly at the top, at the sides. You got to bring the siding back in and the exterior trim. That's replacing a window. But a replacement window is where we have a window like this. You would pull the sashes out, pull the stop molding out, and slide this unit in to the existing jamb. The frame is set in place. The frame is then shimmed to the proper position. The frame is squared by taking a tape measure and measuring the dimension between the bottom corner and the opposite diagonal upper corner. And then we take the same measurement on the other two corners to make sure that they're equal. If they're not equal, then we'll adjust the frame before we screw it in to make sure that that frame is square so that the operational sashes will slide without binding. And screws are used to hold it securely in place. The shim space around the window is foamed. The inside of the frame is caulked, and the outside of the frame is carefully caulked to make it airtight. Our aluminum will serve to trim the outside of the window and cover the old window frame. And we carefully caulk that aluminum and make sure that there's going to be no water leaks.